So for task one, we have to predict the number of deaths in this country. Initially, we use a time series data with date as a dynamic variable. However, we realized that even though we got a score of 0.62, static variables may be better as we can get a better result as well as provide a more macro perspective about the number of deaths in this country, which leads us to model version 2. Model version 2 is actually use static variable. Here we are visualizing the different data set and we are trying to improve with different normalization techniques as well as polynomial techniques. However, what is to note is that after experimenting, we came up with log and polynomial transformation technique, and that gives us a close result of 0.0999. So in evaluation of this model, is it a good model? We felt that yes, it's pretty good. However, there could be this prediction is limited as we are only testing with 40 data points. All right, so in the COVID-19 pandemic, Singapore economy has been hit quite badly. Our project aims to use Straits Times Index as an indicator of Singapore's economy amidst COVID-19 based on other COVID factors. This is important because it allows us to know which factors have a strong correlation and allows us to come up with better strategies to prioritize the key predictors in our coping strategy. So here are some of the limitations and assumptions. The key assumption is why are we using STI to predict the Singapore economy is because STI is relatively stable and we can't find Singapore's GDP every month or every day. So Singapore's stock market is actually quite highly regulated, which allows for a more stable market and which reflects the economy and has a better price discovery. So we are using three kinds of data: Straits Times Index data, Singapore COVID data, and air traffic data. So over here, we are just importing and visualizing them. And over here, we are trying to extract the key features. So all these features are important because we feel that they are important in the Singapore economy, such as time, vaccination, and hospitalization, recovery, cases, and air traffic data. These actually affect how COVID is progressing, and how COVID is progressing. We're going to see the correlation between COVID as well as the Singapore economy using Straits Times Index. All right, so over here, we're just merging the data, and over here, we are encoding face as a categorical data in order to use it. Over here is pretty interesting because we realize that there's a strong correlation between if we use three different category data. So we are removing one to avoid the dummy variable trap. So over here, we are doing a data visualization to see the pair plot and see how each data has a relationship with other data. This allows us to move on to different kind of transformation of data, right? So over here, we are building our model. This is the functions that our class use. However, we like to bring attention to our usage of linear regression. So over here, we are trying to improve on the code given in class and try to modularize it into a way that is better used. So users just need to call the function fit with their factors, and then we will do all the pre-processing here as well as predict. So we can see this in action over here, where we are using all factors as benchmark. So over here is what we are doing in class, but over here, so we are starting to create a linear regression instance, and then we are fitting the different variables, and you just need to predict and print the data as well. So this is actually a much improved version from our model in class, our code in class. So we are evaluating the model. We are creating an evaluating class that essentially prints out all the different evaluation metrics. So over here, we are using R square, adjusted R square, and MAE, mean absolute error. Reason why we are using mean absolute error is because it's better accounted than mean square error in terms of using a multilinear regression model and a polynomial regression model, as well as adjusted R square is more telling than R square because adjusted R square accounts for the different different multivariate factors. So our initial model performed poorly, as you can see here. Why is this the case? So it has a negative R square value. Yeah, and there is no correlation between the prediction as well as the target. It is because the normalization is the results are on a different scale. So in order to improve our model, we are trying to improve in 4 different ways: normalization, reducing the number of features, as well as polynomial transformation and changing the learning rate. So here's how we go about doing it. First, improvement 1 is on the normalization of data. So we just essentially normalize it. And oh, wow, it's a big improvement. So it jumped up to 0.63 is positive, and it's rather high. So we realized that, hey, normalization is really important because our factors are all of the different scale, like Straits Times Index as well as the number of hospital beds. That's a different scale. So now we are trying to change the features, trying to see reduction of features would lead to a better result because we see that, hey, phase two, the phases do not have a strong correlation in the categorical features. So over here, we are trying to use all features and we got a adjusted R-score of 0.63, and over here, we got a adjusted. So after removing some features, which is actually the categorical features, hi, our result did drop. So that may not be a bad thing because it might be that our model is overfitting, but in this case, we would like to think that actually phase has an important factor in the overall prediction. So next we'll stick to using all the features for our model. And next, we'll go on to polynomial transformation. Why is polynomial transformation important? It's because it seems like percentage vaccination has strong correlation with STI. And it's about, from our data visualization, it's about a polynomial relationship of two. So over here, we are just trying out different features. So trying out fewer features and performing different operation experiments to see how it goes. And our conclusion is that at the end, transformation has a positive impact on the model because, as you can see, now he has increased from 0.60 to 0.64 adjusted R-square value. And it's because these features already have a polynomial relationship as shown. So right now we are visualizing the features. So as you can see, a lot of these features have a polynomial relationship. Yeah, so and that's why transformation is important. Over here, our hypothesis is that changing the learning rate doesn't have a much impact on the model because our learning rate is rather low already. So why not just increase the learning rate, right, to increase the level of randomization in the model? So after increasing the learning rate of by 5 times, which is from 0.01 a control to 0.05, hey, wow, our learning rate actually improved. Um, yeah, and increasing our learning rate to 0.1, our learning rate improve even further. This is because it can be seen that there could be randomization of the steps is actually important to improving our model. So right now, I'll analyze our results. And so overall, our result is of 0.69 of close to 0.7 is rather not bad, but I feel that because of our limited data set and that COVID has only been happening for a while, with vaccination only happening in the last year, it's not very accurate to say that this is an accurate model that can be extrapolated well in time. But I think with different kind of data set testing out with different models, our prediction of Straits Times Index could be much better. All right. And because this is a work in progress, so therefore, and much money can be made over here. You can predict the stock market prices accurately. And I don't think that multilinear regression is the best model, to predict. All right, thank you. So this is our web app. And for our web app, the main problem we are trying to solve is how can we help the user predict the Straits Times Index price, which is an indication of the economy given COVID-19 data. Our design enables users to easily visualize the Straits Times Index price and make prediction based on various different COVID factors. So this is the visualization of our data set as well as how STI performs against, how our prediction performs against each factor. Right? So our design allows for easy navigation between the data visualization page, the home page, as well as the prediction page. So right now we're going back to the home page, and we can go back to the predict page, but we can also go predict page from here as well. So it doesn't matter. Allows for user seamless experience. And right now we are trying. Users can input various data and predict the price of Straits Times Index. So right now, we're trying to predict in the future, in 11th of December, how would the Straits Times Index price look like? So by predicting it, it gives us a generated result. All right, so we believe that this web app will be a great tool to help the user understand the effect of COVID on Singapore's economy and to play with the different parameters to visualize the Straits Times Index price. So how do we build this web app? So the front end is built with Flask as well as Streamlit. Streamlit is a very good digital visualization software